Good morning, everybody. We are live. It is May. Oh my gosh, we're gonna get there. 5 weeks left. If we just keep working hard, 5 weeks left, we're done. And the last little bit, we'll just like finish up stuff and just finish up stuff. So here we go. First of all, you got to get your work in, you guys. I know most of you that are watching this are doing great, but there's some that aren't. If we don't get our work in and we get to the end of the year, it's going to be an incomplete, and that's just going to not be fun, because that means you're going to have to either work over the summer or just do it again next year. And that was really going to be a bummer too, okay? So I know it's hard this time, but we can do it together, okay? So let's first of all correct the homework. We've got a review today and test tomorrow, okay? And then the rest of the week, Wednesday, Thursday, and Friday is free if you got everything in, okay? So Wednesday, Thursday, Friday this week is free for you if everything's in, okay? And if you get the test done. So let's take a look at, first of all, the homework. These are the answers I got, okay? So first of all, I drew my trapezoid, and it is an isosceles trapezoid because 3, 3. These lines are parallel, so it's definitely a trapezoid. The mid-segment, which is right in here, its length is going to be about 6.36, okay? And I had to use the distance formula to do that. Number 2, 23 degrees, 157 degrees. Number 3, 70 degrees. Number 4, the mid-segment, that plus that divided by 2 is 24. Number 5, the mid-segment, this thing's going to be 3 because the mid-segment is 1.8. 6, when you solve for x, x is 9. And then they don't ask you to plug it in. Oh, there we go. They don't ask you to plug it in. I will. So I'll say, okay, what is this? So you have to plug it in, 20. You know, then you got to plug it in, okay? And then here, x turns out to be 100. I promise on the test I will ask you what these are, okay? So if you have any specific questions, just ask me, okay? I'm happy to help you, okay? Now, let's take a look at today's stuff, okay? So today what we have is a review, okay? And I'm going to go over the review with you, and I would definitely know these forms, okay? So let's start off. First of all, this thing is regular, okay? And that's important because if it's regular, then all of the angles and all the sides are equal, okay? So, if you want to take a minute to copy this down or just watch, you can. So the sum of the interior angles, that is this formula, 180 times n minus 2. That's the formula you need, and you'll need that formula on the test. So, a decagon has 10 sides, so I'm just going to plug 10 into here. So we're going to go 180 times 10 minus 2, and that's going to give me the sum of all the angles. Okay, so I'm just going to take my calculator, go 180 times 10 minus 2, or times 8, and I get an answer of 1,440 degrees for all of them. Okay, so we're going to add that angle, that angle, that angle, all the way around 1,440 degrees. Okay, no problem. Now, the sum of the exterior angles, it's always, doesn't matter what the figure is, it's always 360. Isn't that weird? No matter what. They all, and these are the exterior angles. There, 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 all the way around. These are the exterior angles, okay? A single interior angle, that's easy. You take this answer here, my 1,440, and just divide it by, well, 10 angles, right? That's all you do. So that answer is going to be 144 degrees for each angle. 144, 144, 144, all the way around, okay? One exterior angle, well, that's easy because you've got 360 going all the way around. You divide that by, well, there's 10 of them, 10 exterior angles because it's a decagon, and you get 36 degrees. Or you know that the 144 plus 36 makes 180. That's another way to do it, okay? Okay, number 2. A polygon has a sum of the interior angles of 900. What is this polygon? Well, I'm going to set it up. So I'm going to set up the formula on number 9 or number 2, and I'm going to say, okay, 900 is equal to 180 times n minus 2, right? That's my formula. So to solve, the first thing I'm going to do is just divide by 180, right? Here's my formula, 180 times n minus 2, but the answer is 900. I don't know what the figure is, so I'm just going to solve. Divide by 180 first. Let's see, use my calculator. What is 900 divided by 180, and I get an answer of 5. That's not the answer because 5 is equal to, well, n minus 2 plus 2 plus 2, n is 7. So this thing's got to be a septagon. That's what this thing is. What is this polygon? A septagon. Septagon. There we go. All right. Number 3. Find the value of x and y. Well, when I take a look at 3, it says it's a parallelogram. And I know that opposite angles are equal or congruent. So these two aren't going to do me any good yet because I got x's and y's. So what I'll do instead is use these two obtuse angles, and these guys are equal to each other. So what I'm going to do is set 4x plus 13 and set it equal to 5x minus 12. Okay, we'll just solve. Alright, so minus 4x minus 4x. We can do that. 13 equals 1x minus 12 plus 12, and I get 25 for the value of x. Okay, that's easy. Now to find the value of y, let's take my 25 and plug it in. So plug it in where? Well, I think if I plug 25 into right here, then I can get y. So let's take 25 and plug it in right there. Okay, so I'm going to go 3 times 25 minus 8 is 75 minus 8, right? 3 times 25 minus 8, and I get 67. Okay, so this angle here is 67 degrees. Therefore, so is this other acute angle. So let's set 4y plus 7 equal to 67. I'll do that over here, okay? Squeeze it in over here. I can probably do that. I'll say 4y plus 7 equals 67, right? Squeeze it in. I know this is 67 because I plugged x in. So if these two angles are equal, so this angle 4y plus 7 is equal to 67. Let's solve it. Minus 7, 4y is equal to 60. Divide by 4, and I think that is 15. There you go. I got x, I got y, okay? Number 4. Okay, number 4. This one's actually pretty easy. Let's do number 4. It's a parallelogram, but you've got to graph it. You really should graph it. So I'll get a piece of graph paper out like this. Let me draw my xy axis here. Okay. Put this down like that. Again, if I get going too fast, just pause it. And okay, there we go. -3, -2. Boom, there's A. -1, 1, boom, there's B. And 4, 1, boom, there's C. Okay, well, there technically are 3 points. There could be a point way up here, which we won't find. Believe it or not, let's see, there could be a point way over here. We won't find that one either, but we're going to find the easy one. The one that seems like the most obvious has got to be somewhere around in here, probably. So if I just count, I know it's a parallelogram, right? I know that this is 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. But man, and the slopes are the same. Up 1, 2, 3 over 2. Up 1, 2, 3 over 2. That's got to be my 4th point, D. And the coordinate of D is at 2, -2. 2, -2. Okay, so I just drew it. Found that 4th point just because it's a parallelogram. Opposite sides have to be equal and parallel. Okay, there it is. 5. Now, if it's a rhombus, here's what we have to know. Okay, here's the trick. It doesn't seem like there's enough information, but there is. So we have to know this. If it's a rhombus, we know that this is 90 degrees. Come on, pen, work for me. All right, I'll use a different pen. This is 90 degrees. Okay, no, that's 90. No, it has to be 90. So, all right, I can do the math. So first of all, let's take a look at this right triangle here that I highlighted. And I know that in a right triangle that these two angles are going to be complementary, meaning they add up to 90. So this angle here is just going to be 90 minus 25. What's that, 65? Yeah, 65 degrees. So this angle here is 65 degrees. Now it gets easy, right? Because it's a rhombus. So that's 65 degrees. Then this is 65 degrees. This is 65 degrees. This is 65 degrees. This 25 is 25 here, and this 25 is here, and this 25 is here. See how easy that was? Okay, because it's rhombus. The angles are bisected. Opposite angles are equal. There we have. Okay. We know it had to be 90 because it's a rhombus, okay? 6. Find the mid-segment. Well, I know that base 1 plus base 2 divided by 2 equals mid-segment. So I'm going to go base 1, 2x minus 2 plus base 2, 3x plus 12 divided by 2, right? Base 1 plus base 2 divided by 2 is equal to 15. Okay, now, solvent. Oh, that's not hard. I got 5x minus 10, or plus 10, my bad. 5x plus 10 divided by 2 equals 15. Now there's two choices. We can either deal with decimals, 5 halves, 2 1/2, or 5, or I'll just, for me personally, since we can avoid decimals, let's just multiply the 2 up. Solve for x, let's just multiply the 2 up. Because it says divide by 2, so multiply by 2, it cancels out the 2. We will have a 5x plus 10 equals 30. Okay, I can do this. Minus 10, 5x is equal to 20. Divide by 5, x is 4. Okay, so now if we take the 4, now we know x, but we need to find the sides. So if I take the x and put the 4 here, and put the 4 here, right? Take the 4 and plug it there. We can get the rest of this answer. All right, so let's do the space first. 2 times not x, but what x is 4 minus 2. 8 minus 2 is 6. Okay, so this side is 6. Same thing here. 3 times my 4 plus 12, because I'm putting the 4 right in there. I get 12 plus 12 is 24. So there we go. I got 6 for this side. I got 24 for this side. Okay. Moving on. Again, if I get going too fast, just stop it, pause it, take a look at it. Okay, page 2, we're almost done. Okay, now, here we go. It's a kite. And again, we have to know about a kite is this. The big key is knowing that there is a 90-degree angle there. Okay, so if there's a 90-degree angle there, then let's see what we got. Okay, so let's take a look first at this little right triangle. I'm going to start there. And then I know, again, that's a right angle. These two angles are going to add up to 90, complementary. So 90 minus 42 degrees. What's that, a 48? Yeah. So right in here, this angle is 48 degrees. All right, so let's get stuff we know. Okay, so if that's 48, then 48's also down here. That 42 is also there. Okay, that's easy. Now let's take a look at the other right triangle. So I got another right triangle right in here. Okay, see the other right triangle? Okay, because if this is 90, then that's also 90, right? That makes sense. I've got another right triangle. Again, these two angles have to be complementary, or they add up to 90, so I'm just going to go 90 minus 68. What's that going to be? 22? Probably, yeah, 22 degrees. Okay, so that I know that this angle's 22 degrees. This angle's 22 degrees. The 68 is also 68 here. Now you got to be careful, because what I'm going to ask probably is something like this. I'm going to say find the measure. That's an M. The measure, that's a Pelican M. I might ask find the measure of angle ABC. This is what I'm going to ask tomorrow, okay? So 42 is not part of it, but ABC is all of that angle right there, right? ABC, so it's just the 48 plus the 68, okay? What's that, 116? Probably 116. 48 plus 68. Yeah, 116. Look at that. I can do some math. And then I'm probably going to ask something like this. What is the measure of angle BCD? And that's just 22 plus 22, which is 44. So be aware of what I'm going to ask, okay? Okay, number 8. Prove that this is an isosceles triangle. Well, trapezoid. Isosceles means two equal sides. Trapezoid, we've got to have one set of parallel sides. So let's check it out. Okay, so I've got to have equal sides, and I got to have parallel lines, and I'll write that down in a second, okay? Let's go ahead and put XY axis down, okay? I'm going to write this down. Okay, isosceles, two equal lengths. Trapezoid, I have to parallel sides. Only one set of parallel sides. So let's prove it. First of all, let's graph it. So I got to do these two things. Two equal lengths and parallel sides. All right, first of all, let's go ahead and graph this. So I'm going to have a point at -5. 1, 2, 3, 4, 5. And 2. Boom. There's A. -5. 1, 2, 3, 4, 5. And 6. 1, 2, 3, 4, 5, 6. Boom. There's B. -1, 6. -1, 1, 2, 4, 5, 1, 2, 3, 4, 5, 6. Uh-oh, that means B's in the wrong spot. Dave's, nope, that's right. And there's C. Boy, oh boy, oh boy. And 2, 1, 2, and -1. Wow. Okay. Wow, does that look like a trapezoid? It does not look like a trapezoid to me. It looks like a kite. Okay, so I don't think this is a nice isosceles trapezoid at all. I'm going to fix it. That sure looks like a kite to me. I'm going to change this. I'm going to fix this because that does not look like a trapezoid at all. It might be a trapezoid tomorrow. This is definitely a kite. Alright, I'm sure this is a kite. There's no way this is a trapezoid. But I think it's a kite. So what is a kite? Alright, the only thing we need really for a kite, so this, we're going to change this up real quick. Change what I said, and I'll fix this later. So if this is a kite, what do I need? I need this side to be equal to this side, and I need this side to be equal to this side. Okay, well I can do that. So first of all, BC, I can count. What's the length of BC? 1, 2, 3, 4. Boom. What's the length of AB? That's easy. 1, 2, 3, 4. Boom. Okay, I got proven that these two sides are equal. Now, what about CD? Well, CD is going to take Pythagoras Theorem. Okay, I'm going to make a right triangle right here. You see my right triangle? This is why I wish we were all in class, because I could teach this better from class. But now remember what Pythagoras Theorem says. A squared plus B squared equals C squared. So if I want to find this diagonal in this right triangle, I just made a right triangle, I'm going to use Pythagoras Theorem to find the length of CD. And I'll do the same thing down here to find the length of AD. Again, I made a right triangle, makes it easier. I've got my A squared plus B squared equals C squared, which is my diagonal. Okay, so first of all, let's take a look at this triangle. So if I want the length of CD, I'll do the work over here. CD, I'm going to do my right triangle. And so my right triangle really is here. 1, 2, 3. So I'm going to go 3 squared plus 1, 2, 3, 4, 5, 6, 7 squared equals C squared, which is really CD, okay? So 9 plus 49 equals C squared. I get 58 equals C squared, or C is the square root of 58. Okay, let's see. Obviously, we should get the same answer over here for AD. So if I want AD, all right, I'll do the Pythagoras Theorem again. A squared plus B squared equals C squared. So I got 1, 2, 3 squared plus 1, 2, 3, 4, 5, 6, 7 squared. It's obvious that they're going to be the same, right? We can already see it. We get the 9 plus the 49 equals C squared. I get 58 equals C squared. I've got the square root of 58 equals C. Now if you want to find out what the square root of 58, if you're curious, we don't need to. We've already proven they're equal in length. That's a kite. If you really won't care what is the square root of 58, just use your calculator and boom, there it is. About 7.6. Okay, so listen carefully. When you want the test, okay, so work on the review, but when you want the test, let me know, okay? Say, Mr. Davies, text me, email, say I want the test, and I'll send it to you, okay? That's all I have. So once you get the test done, you're done for the rest of the week, okay?